If you watch the match, you know exactly what I'm talking about. For the first 70 minutes, England looked entirely in control against Argentina. They were dictating the pace, managing space. They were the clear favorites out there. But then we saw a sudden, catastrophic shift. Welcome to this explainer. Today, we aren't just looking at tactics. We're cracking open the underlying mechanics of that collapse.
You see, this game was really a tale of two entirely different states. In those first 70 minutes, it was pure control for England. But in the final 20, absolute chaos. England's attack slowed to a crawl, their tight defense opened right up, and Argentina simultaneously found this massive, unexpected surge of energy.
So what actually happened? Well, to figure it out, we're going to step outside standard football terminology for a minute. Instead, we're going to look at the lifespan of this match through the lens of a closed electrical system. I promise, once you see a football pitch as a giant circuit board, this game makes perfect sense. Section 1. Fully charged, the opening. Let's define a very specific scientific term, high voltage, but use football terms. In our circuit, high voltage isn't measured in volts. It's measured in fast passing, relentless high pressing, and generating absolute maximum power in every single attack. Right at kickoff, England was basically a brand new battery. They had a strong current and incredibly fast, incisive passing. They were delivering maximum electrical power on every single attack. By pressing high and controlling possession, that battery discharged a massive amount of energy, and they completely dominated the pitch. Which brings us to Section 2, the 70-minute voltage drop, system fatigue. But, as anyone who owns a smartphone knows, a system just cannot run at maximum capacity forever, minute 70. That is the exact moment everything began to change. Right at the 70-minute mark, England's battery started losing significant voltage. The energy output just began to crawl. And this is basic electrical science playing out right there on the grass. These three steps always follow one another. When voltage drops, the current immediately decreases. And when that happens, the entire circuit naturally becomes much, much weaker. Translating that back to the pitch, you could literally see the symptoms in real time. England's players visibly lost speed. Their passes, the current in our analogy, became sluggish and inaccurate. Even their mental processing and decision-making took longer, simply because their circuit was no longer operating at full power. They were running on 1%. Section 3. Argentina reduces the resistance. Optimizing pathways. Now, a football match has two teams, of course, which brings us to the antagonist of our system. Look at the dynamic here. While England acted as a dying battery, succumbing to system fatigue, Argentina did the exact opposite. They optimized their side of the pitch by actively dropping their electrical resistance, removing every single obstacle that was slowing the game down. Our source material notes this perfectly. The current, the ball, flowed freely. Argentina started executing these incredibly quick passing combinations. Smoother pathways, more efficient movement. The ball, our electrical current, was suddenly zipping around the pitch without an ounce of friction. Think of it as ripping resistors right off a circuit board. Every quick pass smoothed the pathway. Every successful completion dropped the resistance even further. The result? A perfectly optimized pathway allowing Argentina's attack to carry maximum power directly toward England's goal, with absolutely nothing to slow it down. Moving on to Section 4, overheating under heavy load, the overload cascade. This severe imbalance, England's failing battery going up against Argentina's freely flowing current, inevitably leads to structural issues. It's a fundamental role of engineering. When a circuit operates under a heavy load for too long without relief, components overheat. First, performance drops, then efficiency decreases, and eventually, inevitable failures begin to appear. Out on the pitch, England's defense mirrored an overloaded circuit perfectly. Because they couldn't handle Argentina's free-flowing current, components literally started to fail. Small, uncharacteristic gaps appeared in their formation. On-field communication broke down. And those tiny, microscopic electrical faults, they quickly snowballed into glaring scoring opportunities for Argentina. Section 5. Completing the final circuit, the inevitable failure. Which brings us to the climax of the match. Argentina really only needed one complete circuit to make it count. Once that freely flowing current bypassed all those overloaded components and reached the final load, the lamp lit up. Goal. The electrical path was officially complete. Argentina's circuit successfully delivered maximum power exactly when it mattered most.
They bypassed the failing components of England's system and completely capitalized on the exact moment the resistance dropped to zero. Section 6. The Engineering Lesson. Energy Management in Sports.
So why does this bizarre engineering metaphor actually matter for us as football viewers? Well, because the main lesson here is that winning football isn't just about having the highest voltage at kickoff. I mean, anyone can sprint for 20 minutes. It's about maintaining stable voltage, keeping resistance low with smart passing, preventing defensive overloads. It's about ensuring your current flows efficiently for the entire 90 minutes, not just the first 70. Ultimately, this whole explainer boils down to one essential thought. The team that manages its electrical system best usually wins the match. Argentina didn't necessarily start with a stronger battery, but they managed their circuit, reduced their resistance, and flawlessly exploited England's overheating system when it really counted.
I'll leave you with this provocative thought to ponder until next time. If we can so perfectly use basic circuits, voltage drops, and overloaded resistors to explain England's loss, can we explain Argentina's entire style of football using Ohm's law? Think about it. Thanks for tuning into this explainer, and I'll catch you in the next one.